welcome. It's Astro Daily, and this is my first video ever, and today we will be talking about outer space. You have seen my channel a lot over the past few years, so you know that outer space is obviously a topic that we talk about. We talk about the things in space, such as stars, galaxies, black holes, spaceships, anything that goes in, on, or outside of outer space. There's no outside the outer space. That was kind of like a trick over there. But to get deeper into this, we are going to be talking about space itself and what it is and what it's not. So buckle up your seatbelts and get ready for the ride, because this can really be an intense one. Get into the deeper meaning of space, and I'm going to go by my definition. So space, it is something that you feel obviously. So let's say, for example, you have a container, or you just have this room I'm in. I'll fill it with a chair, desk, a TV, which is playing the sound right now. I'll fill it with anything. And it is kind of like a place that contains things. And that's how we could kind of see our universe itself in that perspective. We have planets in it, like once stated, stars, floating rocks. We just have so many different things in our vast solar system that is forever contained in it, and it takes up a small amount of space. Now, when we talk about what's inside that space, we will talk about matter. Matter is the things that are composed up, where that's within that certain space or that diameter that we're trying to establish. So we can't necessarily have space. We can't call space something if it's not used. If we didn't exist, then there would be no space. On with that definition, if space was not used at all, then the expansion of it would be limited. It's kind of like if you have a balloon, you fill it with air, and the air slowly takes open that balloon and makes it bigger and bigger. That's kind of how space works. So back to matter, and now we're going to introduce antimatter. And antimatter are pretty much the same thing, but they just have opposite charges, and when they collide, they form pair energy. Pair energy is basically things like gamma rays, ions that float really fast, basically particles that move around really fast. And as we know, this is what technically made up the early universe. It was just a bunch of hot gas particles that floated around very fast until we enter gravity. Now, gravity, it is something that has a force. It imposes a force. It pulls things together. The pulling of gravity, as seen before. Let's say that balloon pops, and now the air from that balloon, it goes into an even bigger space. It's no longer just contained. It's able to separate these different particles, these gas particles. These particles float around, and that's what you could kind of see as galaxies. Now, galaxies, they contain a lot of different stars. They contain a lot of different gases and different types of photons, and they are obviously signs of the ions and the speed of the beginning of the universe that helped it form. And they're made out of mainly helium, hydrogen. They're just big balls of heat that have a lot of energy in them, and they are from the early signs of the universe. Of course, they formed from gas clouds, those gas clouds being from the early beginning of the universe. So by definition, space is something that expands. End of the video. Oh my gosh. So no, there's much more nuance to it, because space has different stages of expansion. Now, expansion, it starts off small, it starts off minuscule, like we were talking about with the matter, antimatter. Then that expands, and then it turns into things such as these particles are moving around at a fast rate. This balloon is exploding. Particles go this way, particles go that way. And now that we obviously see is that they change into different states. They have different states of matter, and these states of matter start off from obviously gaseous, because the gases are forming, they're floating around, they move, and then another phenomenon takes place. This phenomenon is where we bring in gravity. Gravity is able to compact things into more of a denser energy. So those clouds that were floating around, there was a new phenomenon that went on, and it's gravity, where they compacted in and created so much energy. It created mass, and the mass kept just kept building upon each other, getting bigger, creating new types of elements, new types of forms of once just one state, one type of element, a couple elements to more elements. And this created different types of stars that we know. It created different types of planets, rocks. It created more types of matter, and this matter collides with each other. The pure energy is made, everything is made, and now we have more things appearing in space. Space is being filled. It's being filled by different types of elements, different types of states of matter, different types of everything that you could possibly think of. And now we have to create the separation that space is continuous. Space itself expands. We don't know how big space is, but I personally think space potentially does have a limit, but the limit is only defined by what our heat index of when we started is compact to. Because if you do go outside that limit of our heat index of, you know, when we started the Big Bang, all of that sort of stuff, then there might be like just cold out there, like nothingness. Like you'll just be frozen in time because there won't be any heat past that point. You won't be able to move. So therefore it doesn't exist. And you know, we can go as, we could kind of layer it like this. Nothing, there's nothing that exists. And then space is the heat index that exists that we can move around in, because the heat is available, it's there. That's why we can only trace a certain point of our universe, and then it stops because we can't sense the heat that's outside of that point. It's, so you could define it as a heat index. That's why it's Now to go into a more nuanced section of this video, we will be talking about obviously the Earth. Earth is a big rock that we float on. It is made up of matter. This matter allows us to have about 10 G's of force of gravity pulling upon us, and it's like in the Goldilocks zone. Perfect. We have a moon that is inching backwards away from us every year, so about 4 inches, and we are able to live on this floating rock because we have the sun in the center. The sun in the center is floating around the Milky Way back to our sun. Our sun is everything to us. It makes about 99.8% of the mass of our solar system. It helps all of the planets orbit each other. Now, I want you to imagine this. We have the sun, its mass is weighing down on us. Like, it's not down on us, but it's creating a dent in space itself. And that's what mass is. Mass is creating a dent. Now, it's the sun's dent. Earth's dent is slightly way hundreds of times, thousands of times smaller than the sun's dent. And this is what's causing this dent that the sun makes. Its mass, its weight. It weighs so much to the point where it is making everything in our solar system from Mercury to Neptune orbit around it. And you can kind of see it like, instead of like the straight models where you have like everything going perpendicular around it, I personally think the sun is more downwards and we're kind of orbiting above it a bit, but we're not falling into it. And that's kind of where it gets a little bit strange, because most of the models, they show horizontal or orbitation, but no, it's not like that. And we can honestly imagine it. I don't want to get too theoretical here. I obviously have a couple of times, but the earth, the way the sun rotates around the Milky Way, it can be in any direction. It's not one direction. You can't think of it as like we're just orbiting around. No, our solar system could be flipped vertically. It could be diagonal. It can be any type of direction. We are just used to it, basically. And this kind of goes for anything in space. Space has no directions. Yes, you can mark a direction like, oh, there's the North Star, it's north from us. But technically, if you're at another spot, it may be south from you, it may be west from you, it may be east from you. Space has no direction. So in that state, we can be facing any type of direction. We can be anywhere in our universe that we don't know about. We could be around no galaxies, which other than the Andromeda galaxy, And we could be billions of light years away from other potential galaxies if we want to look at it from that perspective. Now, referring to distance, obviously in the beginning of the makeup of our galaxy, we had so much power in the galaxy that things started to explode away from each other. So far, in fact, it created light years. Light years is like the amount of time that it takes light to reach our eyes. For example, the sun, it takes 8 minutes to reach Earth, but another star, it might take like 60,000 years for the light to reach us. A light year is, let me look it up. A light year is 5.87. Oh my gosh. Plus to the 12, like this is crazy. Basically 5.88 trillion miles away. That is a light year. It is that far. What caused so much distance in our universe, in our galaxy, in our making, that we are so far away from everything else in our space? Over with the distance now, let's talk about the safety of space. Space is cold, it's brutal. You could call it dangerous, you could call it safe. You could float in space and probably hit nothing at all because everything is so far away from each other. You could float for centuries, years. There will be nothing that comes in contact with you. Or you could float, pew, one light hits you, hits your leg, hits your arm. It's unpredictable. And with that possibility, people might wonder, oh, how has Earth not been hit by anything catastrophic? How has Earth not been this, that, and a fourth? And obviously, we have to kind of even go deeper into the question. Now, there is a kind of a point where space and time obviously meets. And when you go into that perspective, everything has a really long calendar date on when certain things happen. When our sun was made, it was made, what, billions of years ago, probably 3-4 billion years ago. Earth was made like another few billion years ago. Go past Pangea, go past when Earth had a sister planet, go past when the sun had like 50, hundreds of planets orbiting it. And as you can see, it was a bunch of matter, antimatter points where things were hitting each other, things were colliding, things. And this is kind of the overall point I'm trying to make. Space is like a clay ball. Things keep forming and deforming, and it's a phenomenon where things just are infinite. It's an infinite, hey, you start out with this, you get this, you get photons, you get matter, you get physical rocks. These rocks turn into planets. These planets hit other planets to make different types of planets. Other planet might have more gravity, creates a gas giant. It just goes on and on and on. So within that space, which space is a limited word itself, you have infinity. Infinity is what's going on around that space, but that infinity is surrounded by those ions and the heat that is within the universe, and that heat is expanding, but that expansion heat does have a limit. So I don't know, like I gotta get better at math because I only did a calculus 1 class. There's probably equations that's behind this. I'm taking calculus 2 in the fall. There is no limit. It's just expansion, which the expansion has infinity inside of it. Sorry for the little own question. Is space dangerous? No, space is not dangerous unless you are not prepared for it. Now, obviously, we have astronaut suits. We have all types of space gear. We have all types of technology. If you've seen the human advancement from the early 1950s to now, we are on track to probably become an extraterrestrial species, given that we keep improving, people keep getting smarter, we integrate with AI or something, just simple things of that nature. We are on track to do it. It may not happen in the next 10 years, but it will happen. It will happen within 200 years. Guarantee that. So we come into space prepared. It's not dangerous. We already have enough to go on the moon. We already have enough to make our astronauts not instantly feel the effects of space. We already have enough of that, but we don't have enough in terms of making sure people are healthy in space when they're out there for longer periods of times or duration. We do not have enough in terms of technology to go far enough to view the distant stars and stuff. And that's where we have to remember, within the deepness of space, within everything, space represents our minds, because our minds are forever expanding, collapsing, expanding, collapsing, destroying, rebuilding. That's all it's infinite. It's like it lives inside of us. And that's what I'm trying to say. It lives inside of us. So no, space is not dangerous because we are space. Not saying we are made from space, like I said, proud Christian here, but we behave like space. We have space nature. We, in that sense, are similar to space. It's like saying if we are, if space is dangerous, then we are dangerous. And I did get a little bit too philosophical here, but the point I'm trying to make is, what is space? What is it? And we have to compare it to what we see it as, what it is, and how we can interpret it. And I think we interpret it by looking at ourselves, looking at the past, and looking at things that has happened to obviously form, construct, and build the space around us. So to kind of clarify things, space is naturally just a cold space that, now we fill this space with heat, ions, particles moving faster and faster. Particles expand, particles get bigger. And within this system of heated particles, you have things such as gravity, these particles colliding, so many different things that are happening. And within this space, we have cycles that happen, repeated cycles of energy changing. We have states of matter. You start off with gas, matter, obviously. Then you go down the list to liquid forms of matter, go into solid forms. This matter now has different states of matter. These different states of matter, they have a cycle where they fluctuate into solid to liquid, the solid to liquid. You turn rock, turn it to magma. You get gas collected. It could turn into like precipitation, certain things like that. When you get into the deeper essence of it, it's a cycle that's repeated. But the end of that cycle is, for example, when our sun expands and it erases what we have here on Earth, that can be considered the end of our cycle. But the cycle is truly never ending, because, oh man, it's so hard to do this. Within space, there's cycles, and these cycles have different time periods. These different time periods are junctions of other time periods where they priorly meet, but it continuates, and that's kind of what time is itself. Now, I am a university student. I go to Northeastern University. I am studying electrical engineering and physics, so I don't have every single answer for you right now. But what I do know from my past studies of space, researching, and all the knowledge that I was able to gain over the years, I know I make some sense. I was, as a kid, watching Neil deGrasse Tyson, all sorts of space documentaries, learning all sorts of things. I definitely do need to get further in my academics, so sorry if this video is a bit mixed up, a bit theory based, not overly explained or simplified, or overly explained and undersimplified. Tell me what I could do better for this, for the next videos. I'm going to try to be consistent with these videos. I want to make them as polished and great as possible. If you could do me a favor, like and subscribe, that honestly helps the channel a lot so we could reach more people. Thank you so much for watching. It's Astro Daily here, and I'm out.